Section 2.7 in our BJU Press Algebra 1 textbook. This is about solving multi-step equations. To start, let's talk about how to solve one-step equations and how to solve two-step equations. On the left-hand side, we have x minus 11 is equal to 7. This is an example of a one-step equation. In order for us to solve this one-step equation, we need to do the opposite operation that is happening to the variable. Right now, our variable is being subtracted by 11. The opposite of subtraction is addition, so we're going to add 11 to both sides. And when we add 11 to 7, we end up with x equals 18. On the right-hand side, we have what's called a two-step equation. We have 2y plus 3 equals 5. In this case, we have to undo addition and subtraction before we can undo multiplication and division. So the first thing we want to do is subtract 3 from both sides, and that's how we get 2y is equal to 2. Then we can divide both sides by 2, and that is how we get y is equal to 1. Let's look at this. We have 8b minus 2 plus 6b plus 9 equals 7. In our previous lesson, we learned how we can simplify an equation in order for us to make it easier for us to solve. So there are two ways to simplify an equation. There's using the distributive property to eliminate any parentheses, and then there's also combining like terms. So in this one, we're going to combine like terms. We're going to combine 8b and 6b, and then we're also going to combine negative 2 and 9. And when we do that, we end up with 2b because, and we also end up with negative 2 plus 9 is 7. So from there, we subtract 7 from both sides, and then we divide both sides by 2, and it end up with b equals 0. I notice a slight problem on here. 8b plus 6b should be 14b here, which means that this should be 14b, which means we would divide both sides by 14. However, 0 divided by 14 is still 0. All right, let's take a look at this next problem. This is 12 parentheses a plus b plus a equals 15. So to simplify this equation, we're going to eliminate the parentheses by distributing the 12. So 12 times a is 12a. 12 times 6 is 72. So now we have 12a plus 72 plus a is equal to 15. Then we combine like terms. 12a plus a is 13a. And we also subtract 72 from both sides. So 15 minus 72 gives us negative 57. Then we're going to divide both sides by 13, and we get our answer a is equal to negative 57 over 13. For this one, this is another equation that can be simplified before we solve it. So what we want to do is, I see that we have a decimal 0.4, and it's sometimes a little bit more difficult to work with decimals. So what I would like to do is I'm going to multiply everything by 10. Everything is going to be multiplied by 10. And the reason I do that is so that way I don't have to worry about a decimal anymore. So my first term, which is here, this whole thing, when I multiply that by 10, I get 4 parentheses x plus 5. When I multiply 3 by 10, I get 30. And when I multiply 7 by 10, I get 70. So now I have this problem. Then I can add 30 to both sides, and I get 4 parentheses x plus 5 equals 100. I divide both sides by 4, and now I have x plus 5 equals 25. And then I subtract 5 from both sides, and I get x equals 20. What can we do if we have variables on both sides? So this makes this a multi-step problem because we have multiple things that we have to worry about. If you have an equation with variables on both sides, we have to use the addition property of equality to move all the variables to one side of the equation, because we only want to have to look at one side when we're trying to solve. Let's see an example of that. Let's say we want to solve 2x plus 5 equals x minus 2. I notice that I have variables on both sides of the equation, and that's not what I want. I know that I can subtract x as long as I subtract x from both sides. So again, I'm going to subtract x from both sides, and when I do that, I end up with x plus 5 because 2x minus x is x, so I have x plus 5, and then x minus x becomes 0, leaving me just this minus 2, or this negative 2. Now I've got a two-step equation. I can subtract 5 from both sides and get x equals negative 7. Let's make sure that we check our answers. They should work if we plug them back in. Let's look at example 2. This one we have 3 parentheses x minus 4 equals 4 parentheses x minus 6. So the first thing we have to do is distribute. When we distribute the 3, we get 3x minus 12 for the left-hand side, because 3 times x is 3x. 3 times negative 4 is negative 12. When we distribute the 4 on the right-hand side, we get 4x, because 4 times x is 4x, minus 24, because 4 times negative 6 is negative 24. Now I have variables on both sides. So that means I need to try to get my variables on only one side. I can either subtract 3x from both sides, or I can subtract 4x from both sides. I can do either one, and it's going to eliminate the variable on one of the sides. So I'm going to subtract 3x from both sides. So I'm going to subtract 3x from this side, and I'm going to subtract 3x from this side. And as long as I do it to both sides, it's legal, right? So 3x minus 3x leaves me just negative 12. And then 4x minus 3x leaves me x. And then, of course, the minus 24. Now I've got a two-step equation. To solve for x, I'm going to add 24 to both sides. Negative 12 plus 24 is 12. And so now I have 12 is equal to x. Let's look at if we had done it differently. I chose to subtract 3x from both sides. Will it still work if I choose to subtract 4x from both sides instead? So we're going to subtract 4x from both sides. On the left-hand side, 3x minus 4x gives me negative x minus 12. On the right-hand side, 4x minus 4x cancels, leaving me just negative 24. Now when I solve for x, I had to add 12 to both sides. Negative 24 plus 12 is negative 12. So I have negative x equals negative 12. I divide both sides by negative 1, and I get x is equal to 12. So let's review on solving multi-step equations. Step 1, simplify both sides. You can do that by removing parentheses, by using the distributive property, and also by combining like terms. Once you have done that, you want to move the variable terms to only one side. It can be the left-hand side or the right-hand side, but make sure all your variables are on one side. Step 3, undo the addition and subtraction. Step 4, undo the multiplication and division. Let's look at example 3. This one we have 5x plus 3x minus 4 equals x plus 2. So step 1, we want to simplify. So I'm going to go ahead and combine 5x plus 3x, and that gives me 8x minus 4 equals x plus 2. Step 2 is to get all the variables on the same side. So I'm going to subtract x from both sides, so that way it will go away on my right-hand side. I'll no longer have an x to worry about. But if I subtract x on the right-hand side, I also have to subtract x on the left-hand side. So 8x minus x is 7x, and I still have my minus 4, equals, and on the right-hand side, all I'm left with is 2. Now I've got a two-step equation. So I'm going to take care of addition and subtraction first. So I'm going to add 4 to both sides, and I get 7x equals 6. And then I'll divide both sides by 7 to get my final answer of 6 over 7. Let's look at example 4. So this one, to simplify, I want to distribute first. So 3 times 4x gives me 12x. 3 times negative 5 is negative 15. I bring down the plus 2, equals, distribute again, 2 times 6x is 12x. 2 times 3 is 6. Now I want to get my variables on the same side, so I'm going to subtract 12x from both sides. Oh, I'm sorry, before I do that, let's go ahead and combine negative 15 plus 2. That gives us negative 13. That gives us a little bit easier of a problem to work with. Now we'll subtract 12x from both sides. When I subtract 12x from both sides, something very strange happens. I get negative 13 is equal to 6. The variable cancels out completely, which is very strange. And when it canceled out completely, I got something that wasn't true. That wasn't true at all. Negative 13 is not equal to 6. So that means there is no solution. So no solution, is that possible? It is. An equation can have no solution if there's no value of variable that makes the equation true. So if you end up with a statement that is not true, such as 13 equals 6, then that means there's no solution. There's nothing that you can, no value that you can substitute x for to make the statement true. Let's look at example 5. This one says solve 8 minus parentheses x minus 4 equals negative 2 parentheses x minus 6 plus x. So first thing is we're going to distribute. The 8 comes down, and then negative times x is negative x. Negative times negative 4 becomes positive 4. Equals negative 2 times x is negative 2x. Negative 2 times negative 6 becomes positive 12. And then our plus x comes down. Then we'll go ahead and combine like terms. 8 plus 4 is 12. Negative 2x plus x is negative x. Oh, well, this is interesting. Look what we have here. We have negative x plus 12 equals negative x plus 12. Wow, that means that we have exactly the same thing. We have exactly the same answer no matter what we plug in for x. That means that our solution is all real numbers. We can make x anything we want, and our statement will still be true. This is what we call an identity. So, definition of identity. It's an equation that is true regardless of the value of the variable. We can make that x value anything we want, and our equation is still true. The solution to any identity is always going to be listed as a set of real numbers. So remember, the set of real numbers is that R with a double line in it. Let's look at example 6. 2 parentheses x minus 3 plus 6 equals 3x plus 2 minus parentheses 2 minus x. So the first thing we want to do is distribute. 2 times x is 2x. 2 times negative 3 is negative 6. Our plus 6 comes down. Our equals comes down. Our 3x comes down. our 2 comes down, and then negative times 2 is negative 2. Negative times negative x becomes positive x. Now let's combine some like terms. Negative 6 plus 6 is 0, which means on the left-hand side, all we are left with is 2x. On the right-hand side, 3x plus x is 4x. 2 minus 2 is 0, which means we only have 4x on the right-hand side. So let's subtract 4x from both sides, and we get negative 2x equals 0. We divide both sides by negative 2, and we get x equals 0. So that was the last example for this lesson. Make sure that you review over and do your homework problems.